Hi everyone. Today we are going to take a look at transformations, so transforming functions, which is chapter 2, section 5 of our textbook. So transformations, some of this will be review. However, it isn't really important that we go over these because they will become more difficult, especially when we combine them. And we're going to be using them throughout the year, especially once we start to look at trigonometric functions. Okay, so we're looking at transformations. We're going to look at a few different types of transformations. The first type that we'll look at is vertical shifts. So we have vertical shift. So a shift is just a movement. Vertical is up and down. You might also see this as written as a translation, vertical translation. So shift or translation. So vertical shifts happen when we are adding or subtracting a number outside of where x is located in our function. Let's take a look at a few examples. So here I have Desmos pulled up, and we have up here y equals x squared. So when we take y equals x squared and we add something to it outside of the function, if we add 1 to the outside and graph it, we can see that we have our parabola, and our parabola is actually moved up by 1. If we added 2 to the outside, our parabola moves up by 2. If we subtract 1, our parabola moves down by 1. So you've probably dealt with this before. We're just moving, shifting up and down based on what we added or subtracted outside of f of x. Okay, so vertical shifts. I also want to go over just like the formal definitions too, just to make sure we don't miss anything important that our book puts down. Okay, so if we have a function y equals f of x, and we add some number to it, so we're transforming it, y equals f of x plus c on the outside, then it's a vertical shift up. If c is greater than 0, so positive, and it's shift down if c is less than 0. Okay, so that's vertical shifts. Horizontal shifts are very similar. We're looking at a different part of our equation though. Horizontal shift. Again, you might also see it referred to as a horizontal translation. So here, similarly, we have y equals f of x. However, instead of adding or subtracting outside of f of x, we're going to be adding or subtracting the input f of x. In other words, inside of the parentheses. So when we transform it, we have y equals f of x. And I think our book does f of x minus c. And we have a minus here because it's kind of the opposite of what you'd expect. If we subtract a number, we're actually going to be moving to the right, or moving more towards the positive direction. So our rule is we have a shift to the right if c is greater than 0. And again, we're subtracting c. So if we add x minus 2, we're shifting 2 to the right because we're subtracting a positive number. We have a shift left if c is less than 0. And we can see this in Desmos. We have y equals x squared. If we have x minus 1 squared, well, we're subtracting a positive number, so it should be to the right 1, which is in fact what we see. X minus 3, we're subtracting positive 3, so to the right 3. Finally, x plus 2. Here, x plus 2 you could think of as x minus negative 2. So we can just subtract a negative, and here we can see we're subtracting a negative number, so we're moving to the left 2. So our graph is to the left 2. Okay, so that's how we can determine vertical and horizontal shifts or translations. We're adding either outside of the f of x or into the input, so inside of the input or the f of x place. Next, we're going to take a look at stretching or compressing our functions. So next up, we have vertical stretches and compressions. So vertical stretch or compress. So the shape of our graph stays the same, but the scale is going to be a little bit different. So it might be squished Vertically, it might be squished down or it might be stretched out. It's going to have the same shape, but the proportions will be a little bit different. So for stretches and compressions vertically, we're looking at multiplying on the outside. In other words, multiplying f of x. Our book gives us y equals f of x. And if we transform this by multiplying by some number k, y equals k times f of x. Again, this is outside of our function, so we're not just multiplying the input, we're multiplying our output. Then what we end up with is f of x. Then we end up with a vertical stretch or compression, and we can tell if it's a stretch or compression based on k. So if k is greater than 1, then it's a stretch. If k is less than 1, it's a compression. And one note is our book says if k is less than 1 or greater than 0. So if k is 0, then our function, our output just becomes 0, no matter what. So it kind of destroys our function. If k is negative, then we're actually going to be flipping the function. So if we have a negative k, that implies that we flip vertically. So if we have a parabola, then our parabola is now going to be facing down, for example. Or if it was facing down, it'll now be facing up. So let's take a look at a few examples of multiplying f of x. Here we have y equals absolute value of x. For our first transformation, we have y equals 2 times the absolute value of x, so we're multiplying f of x. And 2 times 2 is greater than 1, so we should have a stretch. And here you can see we have a stretch. So what's happening is we're taking f of x, we're taking that v, and we're kind of pulling it up. You can think about it as stretching it vertically. So what happens is our v becomes narrower in this case. Y equals 3 times absolute value of x will be even more narrow. So we're stretching it even more. And if we have y equals 1/2 times f of x, in this case, our k value is in between 0 and 1. So we are actually compressing or pushing the v shape down. So it's going to become wider in that case. Here. So here we have a wider v shape. So that's how we can stretch or compress vertically. And as I mentioned earlier, a negative value, if we made this negative 1/2, just flips it across the y-axis, or sorry, flips it vertically across the x-axis in this case. And now we have a V shape, a V facing down. Okay. Finally, we will look at horizontal stretches and compressions. So similar to our shifts, the horizontal is going to be a little bit kind of the opposite of what you initially see inside of our function. So horizontal stretch or compress. So our book is looking at y equals f of x. So notice we did the opposite before. So here we subtracted c. In this case, instead of talking about k by multiplying, we're going to talk about k in terms of dividing. So we're looking at y equals f of k times x. And then how this affects the x values is going to be determined by dividing by k. So just hang with me for a minute. So we're looking at k times x, and we can see this transformation by, in other words, this is saying that we multiply x values by 1 over k. In other words, if we divide x values by k, then we end up with our new function. If we have our x values, we keep the same output, but we divide by k, then our function has been compressed or stretched horizontally. So again, depending on k, we can see if it's a stretch or a compression. So if k is greater than 1, then we have a compression. So kind of the opposite of what we had vertically. Vertically, if it's greater than 1, we have a stretch. In this case, if k is greater than 1, then we are compressing our function horizontally. In other words, our function is going to become, if it was a v-shape, narrower. If k is in between 0 and 1, we have a stretch. So we're taking our function and we're stretching it out horizontally. And similar to vertical stretch or compression, if we have a negative k, that means that we flip horizontally. We have a horizontal flip across the y-axis. Okay, let's take a look at a couple of quick examples. So here we have y equals x squared. Here we're multiplying, and notice we're inside of the x squared, so this is the input into y equals x squared. We're multiplying the input by 2. So in this case, 2 is, if we look back at our notes, 2 is greater than 1, so we should expect a compression. In other words, if we look at our parabola, it should be squished horizontally. We go back, look at our function, there it is, it has been compressed horizontally. Looking at y equals 1/2 times x squared, so our input is being multiplied by 1/2. Here, 1/2 is in between 0 and 1, so we should have a stretch horizontally. And again, we see a stretch here. And just like before, if we added a negative in front, in this case, we actually don't change our function because our function is symmetric across the y-axis. So flipping across the y-axis doesn't really change it all that much. If we were looking at something like y equals 2 to the x power, and if we took x, our input, and made that negative, then you can see that we flip it horizontally.